Okay, hello everyone, good afternoon. Welcome to Blue Monday. Let me quickly check if everything is alright. Okay, seems like we are live, YouTube and Twitch for now. Okay, of course, as usual, I did a lot of tweaking over the weekend, but not to the thing that I was supposed to tweak. I was supposed to tweak our keyboard, do the encoders and stuff. Instead, I was tweaking the stream. What looks like finally we have no dropped frames. As far as I can see, seems to be quite stable. So that's a progress. Seems like NVIDIA noise cancelling was killing my 4060, and on top of that, it wasn't really good quality. So definitely not worth it. Yeah, seems to be fine. Okay. Stream is looking good. So, welcome back to the stream. Today, as usual, a lot of work and most probably zero progress. But what can I do? Such is life. So recently we've been working on the magnetic encoders. Just a quick recap. So we were trying to get this little fella working. This is a magnetic encoder MT6701. It looks like this. From the specs, it looks quite nice and doesn't seem to be too complicated yet. We didn't manage to get any readouts out of it, which is very disappointing, but we're not giving up on it yet. I am waiting on ESP32 because there is a library for ESP32. So then we can jump onto Arduino and, instead of doing work ourselves, we can just use an example and hope for the best. So it's always easier to wait than do the actual work. So we put this one on hold for a while. But then we also managed to get some readouts out of another one. I don't think, yeah, I have it over here. Our tiny contraption. So yeah, hand wiring at its best, including very professional reset button, which is this. So it's hooked up to the ground, and the way you reset the board, you just touch to the reset pin, and that's it. Awesome. Yeah, but we managed to get some readouts out of this one, which was very cool. This thing is very precise, very sensitive. So the worst case scenario is that if we can't get MT6701 to work, we will maybe use this one just for the volume, or maybe we will go with the mouse encoders like this one. This one's actually a bigger version. I should have 5mm somewhere. Oh, it's not important at this one. Oh, there it is. Tiny little fella, 5mm. So we can do our volume on this, or we can do it on this one. One is fine because this one runs on I2C, and we can have only one such device on the bus because the address for it is constant. We can't change it, which is also kind of disappointing. I wish it had like address pins, just like I2C expanders, especially MCP. Oh, I forgot the number. 2701 or something like that. Because there were two versions. The newer one had a fancy way of setting up the address. You had to use some resistors to do like a voltage divider, and that really sucked. And the older one, it had just 3 pins, and you could either just connect them to VCC or connect them to ground, and that was it. This is how you set up the address. So you had 3-bit address. It was very cool. Wish this one had that, but sadly it doesn't. So we only can use one such device unless we have separate MCU for each half, which I'm kind of thinking about, but most probably it won't happen because looking at it, we would need to have a matrix instead of direct pin like now. So I haven't really think about it much. Maybe today, if once we are done with the encoder that I'm planning to do today, we'll be printing something. Maybe we can take a look at this one, if it's possible to create a matrix for Chordie that would allow us to use all the keys and some additional buttons that I was planning on using. So if it's possible to have all the keys hooked up to one MCU, maybe dual MCU would be okay. There's definitely space for it because we can put one MCU on the left side can go under the volume, and the other one, I don't have the right side. Oh, but the right side looks more or less like this, and we have more like this from the top. So assuming this is the right side, you're looking only at the bottom part. So over here we have the motion control device, so MCU will go underneath. So this is an option. We can do that if we decide on going with the matrix. So yeah, I think this is about it in terms of the recap for previous stream. And today we will be doing something different. I would like to use this little fella. And I have these dowels. I was pretty much sure I bought quite a lot of them, and of course I can't find them. There's a big chance I threw them away. I need to do some more digging. Maybe they are hiding somewhere. Yeah, so this is a 2mm dowel. Okay, so this and this, I was planning on turning these two into an encoder. But okay, first obstacle is that this one doesn't fit inside. Maybe if we melt it. Yeah, that's something to explore, because I mean, I was thinking that we could use just this. We have this knob already designed. It looks like this. So it kind of fits okay inside. Seems to be fine. So maybe we won't be needing any radical steps just to make it work. So today we have to design somehow a horizontal encoder like this. We have to make it small. We'll definitely go with the 5mm mouse encoder. We already have a tiny mock-up in Design Spark Mechanical. So yeah, I think we should get to work, because we are as usual short on time. So more or less we're gonna try to use these things and some imagination. And of course I forgot about this one. So yeah, I think the most important part is this. So we have this, and this. From the top would be better. Okay, so these three things actually. Today we will try to change it into an encoder, hopefully. See how it goes. I really would like to make it very, very small. I would like to fit into one U, which is one key. And the size for one key, the standard size for MX is 1905. I mean 19.05 by 19.05. But looking at it, we might have some difficulties, but we see how it goes on the CAD. Maybe it won't be that bad. Okay, our favorite CAD program. If you're not using it yet, I highly recommend this one. It's absolutely great. First of all, it's free of charge. Secondly, it's no cloud bullshit like any other. Everything is on your drive. So this is also a very cool thing. And what else? Okay, and even the free version, at least last time I checked, you can use it for paid projects. So unlike, for example, Fusion 360, where you can't use the free version for any commercial project. Here you have no limitation, and actually you can get away with just the free version. The paid one, the features that it has, they might not be that much important, especially for a beginner. And yeah, and the name of the program is of course Design Spark Mechanical. Maybe if I can bring help. Yeah, this is the name, and you can get it from Design Spark Mechanical. And of course, this is not a paid promotion. I am not getting paid, but I just like this. I really like this program. It really helped me to spread my wings, so to say, because I was starting with FreeCAD, and FreeCAD is not the most user-friendly app. And with this one, you can really do a lot of things very easily. And they even have a really good comparison what you're getting if you're like a paid user. Yeah, so for example, the 3D mirror is not that much important because, at least for me, whenever I do something, I will just use the mirror on the slicer. So this is not that much important. This detailing, this once you get really serious and you want to do some let's say you want CNC machining or something like that, so you have to follow all those norms, then yeah, this might be useful. But like the most important part for the paid version, at least to me, is this one. So you can very easily use it for STL import, and then you can just like reverse engineer STL. I think so far, because I tried doing this in FreeCAD, I tried doing this in Fusion. So far, this one was the most user-friendly to me. And of course, import and export in different files, especially DXF. I am using this when I'm creating PCB. I will just export the PCB into the EDA program. And then sometimes when I have all the elements laid out on the PCB, I will export the whole PCB with the elements. I will export into DXF file, and then I will import to Design Spark Mechanical just to see, for example, if I need to correct for some dimensions, like maybe some components are sticking out, then I will just cut the holes or whatever I need. So yeah, this is a really great program. Maybe I will do some tiny tutorial in the future how to get started with it, especially for keyboard building, because as far as I know, there's a lot of folks trying to get into keyboard building, but the biggest obstacle is actually the program. So if you go with the FreeCAD, then you spend more time fighting with the FreeCAD. Fusion is easy, but I think this one is even easier than Fusion. I like it the most. I did so much talking that I needed some water. Okay. So going back to our topic, I think we have this encoder somewhere over here, and I titled it 1U. So this is what it was supposed to be. Okay, what do we have here? And what is the size of this thing? 10 millimeters. Let me quickly check if this is actually what we wanted to use for. Okay, yeah, we have 9.5. So okay, I think it was designed for the 5 millimeters encoder. Where do we have it? I'm sure I had it somewhere. Okay, there they are, mouse encoders, 5 millimeters. Okay, so that's this one. So let's do it differently. So let's make a new component over here, and maybe I will just call it, let's say, vertical. Okay, I'm gonna move it over here, and then we can make another one. So this way I would have like two different mockups, so I don't have to like move it around. Okay, so now I have the horizontal one, and I would just want to move it so it fits. So it's gonna be minus 90 degrees, like this. Okay, let's hide this bottom part. Okay, and let's align this wall to this wall. Okay, I think I missed one more thing. Okay, because there was this thing over here. But because that was our, if we take a look, there was this circle over here, this one. That is not a problem, because what we can do, we can just hit F. This will fill it. So now we have a surface. And now I can take this surface as well and just do 90. So technically we have it. Okay, we have it over here. So, okay, is this where our opening hole was? Let's take a look. No, it was right in the center. Okay, so maybe that wasn't. I just rotated in. I should have rotated around the pivot point. Oh, that's fine. There's no problem, because we can do it like this, and we can move it, and there will be like a midpoint over here somewhere. Okay, so now it's fine. Okay, so this is our encoder. Let's take a look. Okay, so this is how we have it structured. If I take a look at the harness for it, okay, so I guess we will be able to copy the whole thing. Okay, this one is a little bit outdated. Okay, so I think we can remove all those parts, and what I will do, I will just steal the one from here. Control C and Control V, and we are on the right thing now. Okay, and there are a few things that we don't really need over here, because these are for the push buttons, so we can just get rid of that. Okay, so this is our harness. So now we have to rotate it. Would be nice to have the view of the encoder as well. Okay, if I rotate it just by 90, most probably, okay, it was supposed to be minus 90. Okay, it's not gonna work like that. Okay, now it's gonna be fine. Let's do minus 90 from here. Okay, so to align this, I will just hit this circle. And now we can align to this, like left and right. Okay. All right, so we already see, because this bottom part is actually our key, the size of one switch. and we can already see that it's not really gonna fit that well. Maybe if we can move it a little, let's say to here. And okay, so what we have here, these walls, I think we can make them a little bit smaller. So how do we do it? Because okay, let's make it point maybe point 0.4, because we have. So this part where the shaft comes in, it is kind of sticking out. I doubt I will be able to measure it, like maybe. Okay, 0.6. All right. So before, okay, I did already point. Okay, maybe I can just pull it out from this shape. So let's go back to our horizontal. And I mentioned some time ago that these are these features that you can use, like add, subtract, or this is called cut, or no merge. So this is one thing that is available in the settings. So I always keep it on no merge, and hopefully it won't add this shape to our encoder. So I can do it later if I want to. So if I pull it out like that, it will be sticking out, but it won't become the part of this encoder. So if you look at it like this, it is like a separate solid. Otherwise, if I think by default is auto, and then it will just decide on its own if you want to add or if you want to cut from some other solid, which is not always ideal. So I prefer to do it my way. And so now I will just do 0.6. Okay, so okay, maybe we can make it a little bit thinner, because this wall is a little bit too big to my liking. I think we can get away with just 1.2. Oh, it's 3.3. Oh, that is huge. Okay, let's do 1.2. Now I will bring back our encoder over here. So we have to move it as well. So I can just anchor to this wall, the back wall. And then I can just do up to, and I can just like select whatever I want from this wall. Even this will be fine. Okay, it won't be fine because it lifted it up. Okay, one more try. Let's anchor to here. Okay, now it's okay. Okay, how are we looking over here? So far so good. Maybe, okay, remove this one. I think this thing should fit because this is meant for the encoder legs, so this should be fine. Okay, let's take a look. Okay, stream is still on, not that bad. So maybe this time my 4060 won't give up on me. Okay, so what do we do next? We have this wall over here, so we have this opening. So we need a way. If we take a look over here, okay, let's go back to the harness. So definitely we need a way to do some kind of a opening to this one. So diameter of this is 2 millimeters. So I think what I can do, if I hit shift now, so then I will be able to like go from here. Let's remove. So this is like 0.5 from those 2 millimeters. So what I want to do is to do some kind of like a margin for the knob. So maybe it will be better if we. So the question is, do we need to have the whole knob, like even the thick part come in? So this part, should we just focus on the short part or on the thick part? I think the short part is okay, and I think it's like 1 point something, so this should be good. So maybe let's do 0.8 distance. Okay, looks decent. We can always fix it some time later. Okay, and what next? Maybe we can do like a closing wall. Okay, and let's pull it. Let's do it different way. Okay, so I have to remove this one. Okay, so I have this this surface. So I would like to pull it, but I would like to have like to pull it, but to be away from some other part by some amount or some value. So I'll just use the ruler, and I can tell that I want it to be away from the encoder by, let's say, 0.15. Okay, and now we have this surface. Let's pull it out. So now I can cut from it. So I will just take this one, cut this shape and remove this part. So I can get rid of this thing. Okay. Like this, and the encoder. Okay, something is not right. I didn't pull through. Okay, now it's okay. So okay, so this is how it looks like. Okay, so looking from this side, this is more or less how it's gonna be located. I mean, the position of the encoder is not that much important, but so if we look at it right now, so how much space do we have left? Okay, so we have only like 12 millimeters for the knob or for the barrel, if I can call it like that, to rotate. So basically, if I have this encoder somewhere, so basically we have only about 12 millimeters left for this part, for the roller. This one's very nice, metal, and the finger won't slide on it. And how big is it? Okay, this one is 12, so we might be able to fit in maybe somehow with our custom design. Maybe I should sell those encoders because now they are worth a fortune. I think I paid for them like $6 or $8, and now one is 40. That was a good investment. I should have bought like 1,000. No need to play on the stock market, just buy encoders for custom keyboards. Okay, so back to our CAD. So it doesn't look that bad, but there is one more thing. We have our bearing over here, and this bearing is 6 by 3 by 2, 3 by 6 by 2, okay. So let's take a look. Okay, so the outer diameter is 6, so the inner will be 3. Yeah, 3. Okay, so that's okay. I do even have dowels 3 millimeters, and just before the stream I was in panic and I ordered M2, and apparently I won't be needing them. Or maybe in the future before I throw them away. Okay, so the thickness is 2. So I guess this is what we have over here. So this one is, okay, radius 3, so that's fine. Okay, so this radius, this should be 1.5. Okay, let's, okay, so this one is 1.5 because this is M3. Okay, so because we need something to put the barrel on, some kind of a dowel or something. So our roller will be over here, like that, beautiful. It really looks like a roller. And so I was thinking that it would be okay to have a bearing over here, but it might not be that much important to have a bearing. I'm kind of curious how would it rotate with just on a bare plastic, but then it's PLA, so most probably over time it will definitely completely like scrape away whatever there was there, and the whole thing will just like fall into pieces. So I think having a bearing makes a lot of sense, because PLA is not that resistant to anything. Okay, so let me just anchor this over here. Actually, no, I would like to anchor. I have anchor under A letter, so then I can just choose which part of the solid I want to anchor. For example, I can use like maybe midpoint over here. If there is a midpoint somewhere, it's not showing. Okay, maybe midpoint I can't use, but I can definitely use an edge. But I would like to anchor to this wall, and I would like to move everything to the edge of the key. Alrighties, so from here to here now we have how much? We have 10 millimeters. Okay, not great, but not terrible either. Let's see if we can shave something off. No, that is all we have. And this distance is how much? Okay, it's 1.2. I just changed that. So okay, so let's bring back this wall. And we can make a new component. Let's call it barrel. Is 1L or 2L? Oh, let's make it 1L. That doesn't look okay. I need to check. I think it's double A. No, it's just 1L. Okay, I got it right. My English is so good, my god. All right, so we have this barrel over here. Let's see how far can we go. Okay, so from here, can I make it? No, I can't make it like that. I was thinking if I can just hit shift now. It doesn't look like it. Okay, so we can do it some other way. So I can just offset this part. So let's make it 0. I know 15. And now I can do circle from here to here. And I can just remove this. Okay. Okay, let's make it 0.2 from here, but I also need to move it away from here. Point 1. Okay. So one more thing. So we almost have it done, more or less, let's say. So the question is, am I okay with this design? Okay, first of all, there is not enough space over here. So I think we have to lift it up a little. Okay, what's the distance from here to here? Okay, 11. I think I should check with Chordie. What was the size of the MX key when it's because we need it to be taller than switch with the keycap. Because when I was designing it, I mean, when I was building my own keyboards, for example, this one which I can't unplug now, or maybe I can unplug. Yeah, so the original encoder is kind of short. So what I needed to do, I needed to have like a razor for it. So now as you can see, the encoder is kind of in line with the switch. And I think the distance I went with was like 5 millimeters for MX. We can check that with Chordie. Because the issue was that you need it to be a little bit bigger, because when you scroll it like that and it's not tall enough, then at some point you'll be hitting this key when you rotate. So this key will be kind of blocking you. You won't be able to do like a free scroll, which is very annoying. I really didn't like that. So like with every keyboard, I had to do some kind of a razor to that to lift it up. Both MX. Actually, I don't have an MX Anywhere version. Maybe for MX, not so much. I mean, for chalk, sorry, for low profile chalk, maybe I didn't need that. But for MX, it's definitely it's a must-have. Yeah. And for Chordie, I had it like dynamic, because original Chordie had OpenSCAD generator. So there you could even tell when putting in all the values for all the keys and all the stuff, it would like show you how tall is the encoder compared to the switch. So that would give you like the visual cue straight away. Okay, what happened? I think there is something rattling inside. Okay, disconnecting keyboard midstream is not the best idea, I suppose. Okay, so we have our Chordie over here, and we have both MX and chalk. So I think I had a key mockup somewhere. Oh yeah, it's over here. Okay, so this is MX, if I am right. Yeah, and the other ones, the smaller ones, are the choke keys. Yeah, so it's the same level, as to say. So let me just bring back the rest of the keyboard. Okay, something like this. So from the top of the key to the bottom, we have 14.4. So that is more or less equal. I think I have the encoder. As you can see over here for Chordie is even higher because maybe I can do it quickly. If I drop a plane over here and I drop a plane over here, then from this plane to this plane, 733. Oh, hello there, Ruda Brody. What's wrong? I hope it's not the audio. No, it's not the audio. Okay, that's fine. Okay, hit me. That's because I forgot to switch to the PC. Yeah, sorry about that. Maybe I should update my script to automatically change the view even from the workbench. Okay, so what I was rambling about is the height of the keys. So for MX, from the top of the key to the bottom of the key, where the socket is, we have 14.4 over here. And for the choke, we have a little bit less space, we have 4.6. And originally, at least for Chordie, for the MX, I had it a little bit higher than that. So, well, this is not what I want. Yeah, so from here. Oh yeah, hello there. No problem. No problem. I'm good, yeah. I forgot to ask how are you doing? So we are even now. Yeah, I'm doing great. How about you? Monday blues? Good, that's fine. That's fine. Okay, looks like it's also 14.4. And from here was also 14.4. So maybe no, maybe it's not that much higher. So it looks like I was sticking to this value. Okay, so maybe key mock. Let's do like a key over here. Let's make it 1905 by 1905. We actually don't really need to pull it. Can I change the name of the surface? Let's make it MX. And let's move it 14.4. Okay, and let's make another one. Let's make one for the choke key. So, well, actually, I don't have to draw it. I can just copy and paste and just change the name to choke. And then just maybe move it. So for the choke, it was 4.6. Yeah, was it 4.6? Yeah, 4.6. So that's fine. Okay, so this is how it looks like. So for the MX, I mean for the choke, it's not that bad, but it is kind of small. This might be a problem because just like when we were starting our journey with the encoders, we're gonna be hitting this part when we scroll over here, like the scroll goes like this or maybe this way. So this part will be definitely getting in the way. So we need it to be a little bit bigger. So I can't make it too big. I think we're gonna be needing like two sizes. One size for the choke key. No, it's a wrong measurement because I'm looking at the choke is kind of too small. And the issue is that I have MX sockets, I need choke socket. Okay, and now we can have proper size. So it's 7.6. Okay, this changes everything. 7.6. Okay, so it is a little bit better now. Yeah, but still, like when you look at it from this angle, so it looks like it should be fine because it's already above the top of the switch of the keycap. So it shouldn't be really that bad. Yeah, but we definitely need a bigger barrel. How big if you want to make it like 8 millimeters? Yeah, so this is still smaller than for MX. That's still kind of maybe 9. Yeah, looking at it, 9 looks kind of okay. Let me clean up the bottom because we have these things over here. I think we don't need them sticking this much. So let's just go to here. Okay, so now the barrel. Yeah, it looks like it's a little bit bigger. Yeah, but we can always cut it out from this shape. If we make maybe over here. Okay, maybe try to snap. Okay. Okay, maybe from here. Okay, like so. If we go all the way to this part, let's see what happens, if it's gonna be enough space. Okay, and so from this, cut this and remove this part. And that will be easier. Okay, I think we have to make it a little bit bigger than that. So let's make the barrel cutter. And we have to make it a little bit bigger than the barrel itself. So the barrel is 18. So let's make it like 0.15 bigger. Maybe 0.2, just because if you want to do some kind of a shape on the barrel, maybe this will be some more space. Maybe let's make it 0.2. Okay, so it will be easier to cut from the shape. And I will pull it all the way to here. And now what I can do, I can just go to here. I can let's hide the original barrel, and let's do from this. I want to minus this one, so remove this part, and there should be something over here and something over here. Okay. And we still have some other the old cut, so I just need to clean this one up. Okay, what happened here? Sometimes moving doesn't really work for some reason, so we can just pull. Okay, so I think we have a decent cutout. So if you go back to this, and we can do like a section. Something is not right. The bottom is still not properly cut. Or is it? Okay, I forgot about this one. Okay, now it should be fine. Okay. Okay, now it looks good. So we didn't need these. So maybe I can just fix it. Like so. And I will just take this one and this one and cut this part, and we should have a good surface maybe. Let's hide the barrel. Okay, we can remove this part, and it looks like we can pull this to here. Okay, let's do Control and scroll, and we can select the hidden wall from here. And okay, now it looks a little bit better. If I press F, I can't feel it. Okay, let's bring back our bearing over here, and let's bring back the barrel. Okay, and now how does this section look like? Okay, looks okay. I wonder if I can just add these shapes. Oh yeah, okay, that will be better. All right, so well, this is actually okay because it's kind of tall enough. It's even a little bit taller than MX. I hope maybe we can get away with just one size, like one size fits all. So it is definitely bigger than the encoder housing. Yeah. Okay, so now there is the thing that we need to do. So on one side, we need a shaft that goes in. So we can borrow this from our other design. Okay, we can take this part. Let's make a shaft over here. Okay, so it would be nice to rotate it a little. So minus 90 would do, okay. And we have to align it somehow. Okay, it seems to be in the center. So we don't need it to be this long. Actually, I think it would be enough if it was from here, take the ruler, and from this wall, maybe even like 1.2, because it doesn't really matter how deep it will go, because this is gonna be the same part. But what we need to do, if we bring back encoder, where is it? Horizontal, okay, this one. Yeah, so it's kind of, let's pull it like that. So we want it to be all the way to here, assuming that the mockup for the encoder is like correct, more or less. Okay, and from the other side, we need to have like an opening for a dowel. Let me just go quickly grab some dowels from the storage room. As you can see, I have a whole selection. I don't have the print yet, but what was the... Okay, what is the total length that we have over here? Okay, 9.4. So basically, anything that is shorter than 9 should do. Like this fella is 8. Maybe something shorter than 8, maybe this one. Okay, 6. So what we need to do, we need to have an opening. Okay, just more time, because these are M3. Okay, so 3. So I guess we need to make it like 3.1 to have some margin left, maybe. And this one is, they're all the same. Yeah. So let's make it 3.1. And from here, let's make it, it's 9.4. Okay, let's make it 6. Actually, no, that's not what I wanted. I want this one to be 6, -6, like that. So now we can cut this out from the barrel. Okay, we don't need that anymore. Yeah, so the dowel will just go in over here. Okay, so the question is, how does it fit inside the bearing? Let's take something like this. Because I remember that they used to go in like very, very tightly. Yeah. It's gonna be a problem to remove. Yep, it's completely stuck right now. Okay, I can remove it like that. I hope without any damage. Okay. So what should we do next? Okay, we also need a way to mount it. So I guess we can do this part. Something, let's hide this keymocks for now. This part, maybe we can do something like a self-locking, that when we press, it will kind of like grab the bearing like that. But like looking at it right now, I can see that it's a little bit too tight, definitely for now. So what we need to do, because it's just like 6 millimeters, so we definitely want to be at like 0.1 bigger. Okay, let's pull it all the way to here. And now we can, from this, I want to minus this. Okay, so now we have some space left. And this one, this part, like if we keep moving up, this is gonna be more of a trial and error, I suppose. So if I move it up by 1, and maybe we can just grab this edge over here and try to like even it out a little, like 0.12. Okay, let's do 0.12 over here. So what I'm hoping for, that I'll be able to press it from the top. This will kind of like open up and then just grab it. That would help us greatly, because it will be very easy, or should be easy, to install the whole thing. But okay, but then we have the shaft on the other side. Okay, it might be problematic. Okay, we're gonna figure out later, I suppose. I'll be right back. Okay. So next step, what should we do? So basically it looks almost finished, almost finished. What is this part? Okay, I don't need that. Let's highlight everything. And okay, so this is our encoder. I mean, it's not really finished yet, but like the major points, they look okay. Now I'm thinking that would it be okay if we just had the whole thing, like we skip the top wall over here, so the whole assembly would be like a clip in, and it would just hold on this part. Or maybe we can do something similar on the other side, something that would just grab it. This way it would be easy to install, because like the shaft and the dowel, everything will be like in place, so there we won't have to like press it like that or anything like this. The whole thing will just go clip in. I wonder if it's gonna hold well. Okay. Yeah, that would be cool to have it like that. But then there is a question, like, wouldn't it like fall out, like when there's like a force like on the side or something? Wouldn't it like rip it off? It's always better to have it fixed in place than such like easily movable. Okay, I think we should open it up a little, the bottom, because it's okay, what do we have here? Okay, first of all, we don't need this to be this big. Okay, let's clean this up a little. Okay, maybe not this wall. Well, looking at it, these are not really covering the whole length. They are just like from the top, and how long are they? Like 1.6, so maybe if we leave like 2 millimeters space for that. Have one of the other prints, the old one. Maybe front view will be better. Okay, but this one is not bent yet. I had one encoder that was already bent in a way that would fit here perfectly. I think it's okay, it's over here. I don't want to bend another one, at least not yet. So maybe I will just take it out. Oh, this is our bottom switch version. This one works kind of okay. This is like a good contender for the volume as well. I like it that it's on a bearing, yeah, but it's a little bit wobbly at the same time. Let's take a look. Oh, it holds so bad now. Okay, anyway, not important right now. Okay, so we have this encoder right here. So I am curious, like, how much space does it occupy? I think I'm bending the legs even more now. Okay, so this is how it looks like. So there is definitely some space. Okay. Yeah, so we can leave it to be like as long as like the whole encoder body. No point making it smaller. Okay, so now the bottom of our switch. Okay, how can we cut it? So looking at it, so we have to like one line over here for sure. And then this is the end, so this will be another wall. So I think like a rectangle like this. Okay, I was supposed to make the rectangle. So something like that should do. Okay. So like from the bottom, this is how it's gonna look like. So this is 4.2 because I think I copied from Chordie maybe. I can't remember because the size looks kind of familiar. 4.2. Okay, so I guess I have to pull these legs to be over here, so that will be easier to print, at least for now. All right. 1 second. Quick look at the task manager. Okay, doesn't look that bad. GPU at 60. So at least we are not dropping frames yet. Righties. Okay, what do we have here? So this is our whole key, more or less. Okay, we won't be able to print this like that. Okay, and most probably we're gonna have an issue over here, because if we apply pressure from the top, I don't think this will hold that well. Most probably it will just we will be able to push it out from the socket. Okay, but we have this thing over here, but I don't think it will sustain. We can't really rely on this part. This can't be really blocking. Okay. Well, what we can do, like assuming we have a bottom plate, we can just block it from the bottom, but that is not really a good solution because like for Chordie, that might work, but if you have a different keyboard, that will be a problem. Okay, that is problematic right now. Okay, but definitely for the print, what we need to do, because we can't print this. Okay, that's gonna be also difficult to print from what I can tell. Because we have these like walls hanging over here. And this one. So this one we can pull to the bottom. But we can do this with this because this is where the leg's gonna come in. And we can't print it any other way. Okay, why is it kind of like high? Can I pull this up to here? Would it like affect the barrel? No, looks like there is some space left still. Okay, so we need to find a way, at least for now, to print this thing. And what we can do, well, we can just maybe create a shape from here. Something like this. Would it work? Like if we... Something is not right. Why did it... I think it snapped wrongly. Sometimes you have to be worried because it can snap to some like place that you don't like, or you don't want. And then you have like a strange angle. Instead of 90 degrees, you have like 99.6. Okay, but we still can't pull it up all the way. That won't do much. Okay, I will pull this to here because it's still like the part of the encoder anyway. I wonder if I can move this wall like this to here. I can just control and scroll and I should be able to select the vertex, and I can select the vertex. Okay, nothing happened because we have the surface over here. Let's see one more time. Okay, so maybe I can really... no, it's not really what I want. What is the distance from here to here? Okay, 0.18. No, it's not that bad. Maybe instead of this, I can move this one. We have to change directions. I can hold Alt and just click here. And now I can just follow this line. Yeah, maybe it won't be that bad. Okay, I want to move this one, so we need to change direction as well to this. Okay. Damn it. Okay, one more time. I think I moved the wall and I didn't notice. So it was a little bit crooked. Okay, now it should be fine. Okay, Alt and the direction I can choose, like any direction. I can choose this direction. I can choose this direction, which I actually need. Okay, I want to move in this direction. Okay, I hope this trick won't really affect it much. Okay. I have to move this over here because this wall will go all the way to the bottom. It looks like it's gonna be difficult to remove. Okay, I want to pull it to here, and I want to pull this one as well to here. Okay. So this looks like something that can be print actually. Okay, maybe let's move this one to here as well. So we have a better... Okay. I think we can hide the shaft for now. Okay, so this is how it's supposed to look like. So the encoder will go like from the bottom to here. And then we have bearing, which should technically, we should be able to catch over here. Well, what we can do, we can extend this. Maybe we can move it by, let's see, like 2.4. Minus 2.4, the other direction. Oh. Okay, maybe just leave it like that for now, because if I make it a little bit thicker, then it might not really like bend, so we won't be able to push in the bearing. Okay, so with the encoder inside, it looks more or less like this. Then we have our shaft, which is part of the barrel anyway. And then we have the bearing. Okay, something is not really aligned over here. Okay. Am I seeing it correctly that it's it won't fit? It's too thick? How did this happen? Okay, 9.7. Oh, but I think I took the harness from the other one, so it should fit anyway. The one that was okay. So now the question is how do we really, how can we like mount the whole thing? Because like with all those walls around, well, there won't be enough space. Like if we have the barrel, so like if we put the barrel like this, so it won't fit. There will be not enough space to like push it in. Yeah, so maybe we should really consider this without the top wall. And I think we should pull this one. Can I change direction for that? Okay. I went off screen a little. Yeah, so this might make more sense. So we will have the top exposed, and then we can lock it in a way, maybe from the bottom, so that it will be not that much possible to like push it through, and hopefully it won't be also that easy to pull it out, because otherwise we won't really fit into this space. Like we won't make it into 1905. At this moment in time, I don't really have an idea how to approach this. Yeah, but it would be cool to see it in action. Yeah, so it looks like this part is okay to print. Let's save it. I think I can close Chordie without saving. We haven't done anything there. Okay, so let's export this, and okay, we need a fancy name to distinguish. Let's make it horizontal mouse. I don't know, one U. Okay, so that will be this. And then we need one more thing. We need our barrel. Okay, we need to export this one as well. So it's gonna be horizontal mouse 1U barrel. And do we need anything? Okay, my bad, because I missed the shaft. Actually, its shaft should be inside the barrel. Where is the barrel? It's here. Okay. The cutter we can remove, and actually let's just call it shaft, and we can just put it over here, so to avoid any confusion. Okay, now it's correct. Okay, and that will be it in terms of printing. Let's start Bamboo Studio. Okay, and let's prepare our stuff. Oh, we are even here, so we have the barrel. Okay, let's rotate it like that, and let's add one more thing, which is our holder. Let's arrange. Okay, looks good. Looks good. Okay, slice it and print it. Okay, what is happening? Okay, it's running. All right, so that is okay. Oh, so the print time is not that bad, 17 minutes. So maybe we can have it even before the end of the stream. So we will be able to tell how many mistakes we have made and how many things need fixing. Yeah, but it's always like that. Okay, this one is 3.1. Okay, so this should fit. This should fit nicely. Okay, what else we need to fix today? So we have this one thing printing. Sadly, I have not received the controller for ESP32. It should be arriving soon. Maybe we can do it on Wednesday or maybe Friday, the latest. I hope, I really would like to have it working, MT6701. Yeah, and other than that, so I was about to take a look at Chordie if we wanted to do it on a matrix. Okay, how do we approach that? Okay, I think the print bed is... it's clean, so that's fine. Okay, so this is Chordie. So if you want to do it with two MCUs, we have... okay, how many keys we have? Okay, this one is the old version. So the current one will have even more keys. Okay, if I remember correctly, the left side, which is this one. Okay, this is left and this is right. Oh, this is right. So the left side had, okay, so we have encoder over here and diodes. Okay, so the left side seems about right. Oh, maybe not. Because there was a volume as well. So on the left side, we have volume over here. So it's gonna be 3 more, actually 5 more inputs. Actually, no, this one is not an input. This will be common. So, okay, this is common and this is common. Because you have A and B. Can't really see A and B. And this is the switch. And this the common pin for the A and B and ground for the switch is like 1 wire, so we don't really have to hook it up to the MCU. Okay, so this is the left side, and we have over here 1, 2, 3 as well. Okay, we won't have the switch on our horizontal encoder, or maybe we can think about it. Okay, maybe instead of doing that, let's see if it's feasible to have a... If we can fit in like a switch, like some maybe tiny switch over here. Okay, let's... yeah, so... Okay, so we have this thing over here. So if we can just fit like a tiny switch over here, just under the bearing, so like the bearing will be sitting on the switch. I do have a lot of different switches. Let me grab, I have a box with very, very tiny ones. So maybe we can find something that would be the size of the bearing. Okay. So our bearing is how much? It's like 2 millimeters. Yeah, bearing is 2 millimeters. So we should ideally have something smaller than that, so we can fit it inside. And we do have some like very tiny ones over here. This one is almost invisible. But how big is it? Okay, this one is 3 millimeters, and it's already very tiny. I don't think we can find anything smaller than that. Yeah, this one seems to be the smallest. Everything else is rather huge. But, okay, we don't really need to have it like this. How about, what will happen if we put a switch like, if we do section over here, just rotate a little. Okay, so this is our switch. Okay, we can't really see it. Let's do section on this one. Oh, now it's better. Okay, so what will happen if we stack a push button over here? We won't be that much limited with space, so we can use a bigger one. The only issue is that we have legs sticking out. So the legs go like this. And can we bend them a little? We can't really bend them because we have the barrel over there, and on the other side there's the back wall of the encoder. But maybe, okay, once you have it print, we might have like a better view what is happening. Yeah, that would be ideal if we can have a push button over there. Now this one's obviously too big. But looking at it, it would kind of fit almost perfectly. Yeah, and we can still push it. Then this might actually work. Okay, that is interesting. There isn't much space over here, but like we can always solder the wires on the back side and have the switch over here. Yeah, this might work. If we have something smaller, maybe smaller switch like the one that I just showed you. How tiny is it? Oh, this one even fits like... Yeah, that one is almost okay. Very easy to press, especially if we like push from the top. And actually we do have some space at the back. Or do we? Well, not much. If you look at this wall, 1.2 millimeters, so it's not that bad. We could definitely leave some space. So for the wires to go from here, and then we can print like a shelf or something like this, and the switch will be like on top. I mean, this is the switch, and this is like the thing that will be holding it. And looking at this one, the issue is that it's gonna be difficult to solder anything. We also have different ones. Okay, like quite a number of them fit. This one looks easier to solder. Okay, it looks like we do have some options right here. Okay, so what we need to do is we need to wait for the thing to print. Okay, so definitely there are some possibilities that we can take to make it switchable. That would be actually cool, although I don't really have that much use cases for this. I'm only using one scroll with the button, and the button is meant for clicking. So if I'm like scrolling through Reddit and I happen to stop on a link, then I don't have to use my left hand. I am so lazy that I can just push the scroll wheel and this will open the link for me and I can continue scrolling. So that is the only use case actually. It's not that much important, but it would be nice to have, and like we still need to block it somehow to falling like through the bottom. So instead of like wasting plastic, we can always put a button over there and just a little less plastic, and this might actually work since we'll be going all the way from the top. Let's take a look at the printer. Where are we? It looks like it's finishing soon. Okay, I think it's almost done. Yeah, I can bet that the bearing won't fit into the opening. Oh, that's fine. Don't ask me how many tries it took to have a trackball and that would like clip on the ball. Like my initial design was just like flat without anything that would hold the ball. So every time I move the keyboard, the ball would just fly away. And I would also lose all the bearings that were inside. That was very annoying. So that was a lot of pressure to make it work. Okay, the print is finished. I would just go pick it up. Okay, we have those parts over here. They look kind of nice. Let's see if anything fits even. Okay, let's start with the bearing. Okay, it fits. It's even kind of too loose, but yeah, we can go a little bit higher. But it's okay. It's not that bad. Okay, where is our encoder? Okay, that's the one with the bent legs. We need a straight one. And I can't find it anywhere. Well, I had it just now. Maybe I should rewatch my own stream just to figure out where I put the part. Okay, anyways, not gonna waste time looking for it. Luckily I have more. Are these 5 mm? No, these are 7. Okay, finally I have the 5 mm one. Not sure where I put that 5, or maybe it wasn't 5 after all. Okay, so it should go like this. I think I know what's gonna be. Yeah, I hope I can. Oh, it's very tight. Okay, let's see. Oh, yeah, right. It won't fit. It will only fit from the bottom. Yeah, I forgot about this. I mean, I can bend them in. I can't push it from the top, or maybe I can. If I try to bend. Yeah, but this kind of defeats the purpose. Okay, one more thing. We need the dowel. Okay, let's take the short one. I think I should have made it like 3.15 instead of 3.1. I think it's a little bit too tight, and we don't really need it this tight. Yeah, it's gonna be difficult to fit in. It's not getting in. Ah, damn. And I think it's too small. Yeah, it won't really go in. Let's make it 3.2. Okay, so it's 1.6. It was... Okay, this should be good. Okay, maybe we can print it fast before I close the stream. it's not really, I don't think it's gonna work. Yeah, let's just try without it. Okay. Okay, I think I broke something. Yeah, I think we need a little bit more tolerances because it's kind of scrubbing on the walls. Yeah, but seems like can't really push it down that much. Well, with this approach, maybe we don't really have to worry about the bottom part, about the legs. Okay, something is wrong with the stream again. Okay, what is happening? Should be okay, I hope. Yeah, anyways, let's continue. Yeah, 4060 is not a good GPU. Seems like it's not good for anything. Gaming, definitely not. And even if you want to stream with it, it's a bit crappy. Like, it's not really doing much at the moment. I mean, of course, it's encoding dual stream, so that's something. And I have NVIDIA background removal. So, yeah, but like, I'm getting messages from YouTube that like the stream is unstable. Well, at least Twitch is not complaining, so that's something. Okay, going back. So, yeah, this might actually work for us. Like, we do have some space over here. So maybe we can remove this wall in the future. So we have access to the pins over here. Let me grab something. Yeah, this will be better. Yeah, so if we remove this wall, so the pins will be exposed from this side, and then we can have a push button over here. If it's gonna fit. Okay, let's take a look because we don't really have that much space right now. Okay, definitely this one won't fit. This one is too thick. That one is also too big. So we have to pick one from the very, very small ones. I mean, this one is maybe not that small, but when you look at it, it's not that wide. Nope, it won't fit in. Okay, that is disappointing. And neither of them will fit in like that. Well, actually, we can also remove this wall as well over here. Just a little. So maybe then we can fit in one of the encoders. Oh, this one should fit, okay. It's gonna be pain to solder. It looks like this will only fit if we remove the wall as well. Oh no, it fits. It does fit. Very tight, but it does fit. Yeah, so we could have like the bottom part reserved for the switch and some like canals for the wire. Okay, so it's not that bad. Better than I expected. Okay. Looking at it, it is kind of okay. Yeah, if you only had the dowel, okay, it's gonna finish printing soon, hopefully. Maybe then we can... Yeah, but it's not that bad. The only issue is that we need something that is that will hold the finger. This is very slippery and just plastic. Sadly, it doesn't seem like there are any other knobs like default ones that we could use because everything is bigger than that. Or if we have like the same thickness, then the diameter will be different. And the print one are not really that great. Oh, we can put some carvings on the side, so that should be okay. Yeah, but it rotates quite nicely. It's a little bit too tight. We definitely need to add some more spacing on the left and the right side. Okay, how is the print going? Okay, should finish soon. Remaining 2 minutes. Okay, not bad. Actually, this is gonna be the fastest part now. It's gonna be printing shaft, so that should be fine. Yeah, my GPU is at 60%. Okay, I don't really understand why is YouTube complaining. Okay, anyways. Should be good. Okay, 2 minutes left. I really would like to check this barrel before we finish the stream. I hope 3.2 will be enough to fit in the dowel and to make everything hold. Yeah, but it looks promising. I wish there was like a metal barrel or metal knob that we could use. Metal is very nice to use on the scrolling wheel. And well, actually, one more second. I do have a mouse wheel over here, but it's gonna be too big. It's huge. Just look at it. Yeah, but okay, it's kind of big. I can agree to that. But it's not that much bad. Let's try to push this one out from here. Okay, let's take a look. maybe we can find like a solution in the least expected place and just use the just use the mouse wheel. That is broken. Awesome. I knew I'm gonna break it. Oh no. Seems like we might have a problem getting this one out. Okay, I will put it on the side. That is quite surprising because it's the same shaft as I used on the other ones, and that one was quite okay. It didn't really need this much force to take it out, but okay, that's fine. Okay, we have another one. Okay, it's much bigger. Yeah, I think maybe next stream we might try to adapt for this kind of wheel. I don't know if all mouse wheels have the same diameter. I would assume yes. This should be kind of standardized, like most of the parts for the mouse. So maybe we can make it work, but that would be the best solution because, mouse wheel is always nice to rotate. It's always some like rubbery surface or metal surface or whatever. I think I have a metal one somewhere as well. Or maybe I just lost it already. Yeah, we'll find it for another stream maybe, if I'm lucky enough. Okay. Okay, that one is finished. But I don't think I will be risking breaking another encoder. I think I will just tap on this because this one is already... Where is it? I don't think I'll be able to take the plastic out from it. It's stuck for good. But that might be tricky. And actually, I don't know. Maybe I just push it too far. Yeah, possible, because I think there was... it's not uniform size. The whole... I think it shrinks at the back somewhere. Yeah, that might be the case. So it should be shorter. Okay, anyways, I will fix it off stream. So I won't be testing this one because I don't want to break another encoder. Cool. Anyways, we do have some good progress today. There is a light in the tunnel that we can have a decent horizontal encoder. Maybe we'll be also able to use the mouse wheel for that. So we'll check this out on Wednesday. What else? Yeah, I need to try to fix the encoder and make the shaft shorter for our current one. Yeah. So I guess that's it. We will continue with this encoder on Wednesday. Maybe we'll get the ESP32 by then, so see how it goes. If we are fast enough, maybe we can jump onto ESP and check the magnetic encoder as well, the one that didn't work. And for now, I think that's it. Thank you very much for joining and for watching. Have a great evening, and I see you on Wednesday. Bye-bye.